Okay, so for number 2, we're looking at someone standing on an elevator, let's say, that is moving up at 2 meters per second. That's the acceleration. And we have to find all the forces that are acting on this person in the elevator. So first we have to define a positive direction. So I define the positive direction as the upwards direction, or positive y. And we have to find all the other forces that are acting on this person. So we have the normal force that's acting on the person, and also the mass times the gravity, which is 100 the mass times 10 the gravity, 1,000 newtons. So now let's try to find what the normal force is. So in order for this person to be stable or in equilibrium, the normal force has to be 1,200 newtons. Now let's see how we got there. So first we start with Newton's law, that the sum of all the forces in the y direction is the mass times the acceleration in the y direction. Then we can move on to add the normal force. So the normal force minus the mass times the gravity is equal to the mass times acceleration of the y, because this is the sum of all the forces. So now we can rearrange this to say that the normal force is equal to the mass times the gravity plus the mass times the acceleration. So we know these values. We know that the mass times the gravity is 1,000 newtons, and we know that the mass times the acceleration is 2, which is the acceleration, times 100. So that's 1,200. So that is what the normal force is. That's the value of the normal force.